This is the first concept of esters. I told you that for organic chemistry, the most important thing is the IUPAC name. What is the IUPAC name? What is the IUPAC name of esters? IUPAC name of ester is alkyl alkanoate. What is the IUPAC name of esters?
Alkyl alkanoates.
Yes. Now, this is very important, Mikhail, that you have to learn these names. Now, can you identify the group? R, C, O, O, R. I always emphasize a lot because when you see the past paper, when you will see the past paper questions of organic chemistry, you will understand that everything is this actually code R, C, O, O, H, R, C, O, O, R, R, C, H, O, etc. This is the main code. Esters are alkyl alkanoates, carbon with double bonded oxygen with a single bonded oxygen. Look at this group. This is the functional group of carbon. This is the functional group for esters. How we used to name ester? Ester name has two parts. Quickly recall, one part is called alkanoate, which is containing the carbon with double bond. Carbon with double bond becomes the alkanoate, and carbon with oxygen alone is alkyl. Okay, now look at this. They merge to form alkyl alkanoate. Look at this compound example. C double bond O, CH3, OCH3. So how we name it? Look at this. Ethanoate, methyl ethanoate. This is how we name an ester. If we merge it, it becomes methyl ethanoate. This is methyl ethanoate, and this is how we name an ester group. So now give the heading esterification, the same chapter. Give the heading esterification.
Okay, done.
Now, what is esterification? Reaction of a carboxylic acid with an alcohol using an acid catalyst to form an ester. This is the definition. What is esterification? Esterification is a process in which a carboxylic acid, look at the word equation, an alcohol reacts with a carboxylic acid in presence of concentrated H2SO4 and makes ester and water. Concentrated H2SO4, why? Because it is an acid catalyst and it is being used here as a dehydrating agent. So let's quickly recap. We are doing esterification. Esterification means making esters. How we make an ester? We take an alcohol with a carboxylic acid, concentrated H2SO4, ester plus water. This is called esterification. Concentrated H2SO4 is here to absorb water. Why we need to absorb water? Actually, water is on the right side. Water can reverse the reaction. You can identify the reversible sign in this reaction. Now you have to look at this screen. You have to copy this after giving the heading.
Done.
Now, concentrated H2SO4 is used here as a dehydrating agent. What's a dehydrating agent? Dehydrating agent is actually something which absorbs water. It is used as a dehydrating agent, which means it can absorb water. This reaction is called esterification. So right under it that right under it that carboxylic, H2SO4 is used as a dehydrating agent. So please repeat the concept. During during esterification, for esterification, we use carboxylic acid. We use H2SO4, sorry. We use H2SO4 as a dehydrating agent. What's the meaning of a reversible reaction?
It can be
It can go back.
convert. Yeah.
A reversible reaction is that which goes back. It can occur in both directions. Now, why we want to remove water? This is a very important issue because esters have a strong tendency. Esters have a strong tendency to react with water. Look at this. Look at this. Ester is ester is capable to react with water. Now, we can stop this reversal by removing water. Now, look at the symbolic language. As I always tell you that this language is crucial. Look, when you write OH, it means it is alcohol. When you write COOH, this is carboxylic acid. When you write COOR, look at this. This is ester. This is the crucial important thing for organic, how you identify an organic group. Now, that is the point to note. You have already written the word equation. Right under it that H2SO concentrated H2SO4, use copy this box.
So can you go back to the structural formula?
Are you talking about this one?
Yeah, 1 second.
Okay.
Why does the R have an apostrophe?
It means that it may be the same alkyl radical or maybe different. R and R prime. Why there are two R prime? There are two R prime actually because the two R primes are used. The two R primes are used because one may be CH3, so maybe the other one is C2H5. It is not necessary that they both are the same.
We're done.
Okay. Now you have to copy this box also. Concentrated H2SO4 is used as a dehydrating agent. Only the arrow box.
Done.
Okay. Now look at this. Now look how water is formed. Alcohol will lose OH. Acid will lose H. Now this is a very helpful information that how water is coming out. Alcohol will lose OH and carboxylic acid will lose H. And that is how water is formed. Now I give you an example. C2H5OH, which is alcohol. CH3COOH is ethanoic acid. CH3COO, C2H5, ethyl ethanoate, and water. You have to copy this example.
Done.
This is called esterification. Now look at the summary of esterification. What is esterification? Esterification is a process in which an alcohol and carboxylic acid react together. H and OH, they form water and you get an ester group. Remember, in this reaction, concentrated H2SO4 is used as an acid catalyst. This is an example of this reaction. Many examples can be given here. Now, our next concept, esters are sweet smelling compound, a very important concept. Esters have unique smell, and that is why esters are used. That is why esters are used in artificial flavoring and artificial synthetic perfumes. Major commercial uses of esters involved. They are used as solvents, they are used as perfumes, they are used in flavorings. You must have seen the artificial flavors like in juices, like in ice cream, etc. So a famous example is propyl ethanoate, is an ester that smells very strongly of pears. Owing to this, it is commonly used as a food flavoring. This is another which has a fruity odor and it is used in perfumes. Now, I take the example of ethyl ethanoate. This is an ester. This is an ester like ethanol is a famous example. Ethyl ethanoate is a famous ester example. So you have to give this heading now.
Done.
This is ethyl ethanoate. It smells like a pineapple. It smells like pineapple, and many companies are blamed that they use artificial smell in fruit juices, apart from their claim that they are using natural resources, but natural pineapple and these fruits are very expensive. So they mix some food grade level esters which can be digested, but they have a smell, much stronger smell than a natural pineapple. Now look at the structure, CH3, COO, CH2, CH3. Here you will understand why there was R and R prime. One is the yellow and one is the blue. These are the two alkyl radicals. So you have to copy this structure. Have you copied it?
Yeah, done.
Good. Now, this is called ethyl ethanoate. It has a typical smell, and we can get this smell in our, if you have a taste of buying those tins of pineapple juices, ethyl ethanoate has this displayed formula. This is ester bond, COO. C-double-O bonds, double oxygen. This is called ester, and how we make it, we use ethanol and ethanoic acid. Let us take this as an example. And this is the reaction procedure that we have a container, round bottom flask, we have a thermometer attached it, we have a condenser. So we take alcohol, and these type of questions, they come in paper 6 also. Paper 6 ATP is a parallel paper, and your school will decide about it. And have they started paper 6 in school by now?
No.
Let's wait for more how they decide about it, but we have started some work on it. This is how ethyl ethanoate is made. Now we have to remember the ingredient ethanol plus ethanoic acid. So let's write down the word equation. Let's write together the word equation ethanol plus ethanoic acid, reversible reaction, ethyl. So write with me, ethyl, ethyl,
1 minute.
sure, plus water.
Okay, I'm back.
Now look at this reaction, ethanol plus ethanoic acid. And this is a reaction between, this is the reaction we are making for in order to make ethyl ethanoate. Now copy this word equation.
Okay, done.
Okay. This is the apparatus we have mentioned, and this is the reaction which can make it. This is a experimental procedure. Now, this is the end of the chapter. We have only one chapter left. So we have to do polymerization, then organic chemistry, which is the biggest section in your chemistry in terms of quality, in terms of size. But we will first do some questions before we start the last chapter. I'm showing you some questions, MCQ, you can do with me. What is the structure of buta? You can look at the notes, you can ask me anything. So we are doing it together, but you have to think yourself first. What is the structure of butanoic acid? But means 4 carbon. Okay, butanoic acid means carboxylic acid. Carboxylic acid is actually RCOOH. Okay, now I have to fill. But means 4. Okay, so I will do CH3, CH2, 2 carbon, CH2, 3 carbon, and then COOH. How I know that I have to fill 4 carbons? Can you hear me?
Yes.
How I know that I have to put 4 carbon? Because but means 4. Meth, methane, ethane, propane, butane, like this.
So what is butanoic acid again?
It's a carboxylic acid.
And
It is a carboxylic acid. It is a carboxylic acid which contains 4 carbon atoms.
so how would you know how to draw butanoic acid?
You have to remember the basic structure RCOOH. Remember the file I had sent you to memorize the structural formula?
Yeah,
Like
RCOH.
yes. Then RCOOH. Now I have to fill total 4 carbons. So I will draw CH3, CH2, CH2, and then this will give me 3 carbon. 1 carbon is already there. So it will be CH3, CH2, CH2, and COOH.
Is it because butane is C4H10?
But this is not butane. This is but means 4 carbon, but this is not butane. It's butanoic acid. The name is not alkane. It is an alkane derivative. So half of the word is but you won't take butane, you will take butanoic acid. So
So how did you get CH3, CH2, CH2?
This is, remember the structural formula, remember that. It's a pattern, CH3, CH2, CH2, CH, a pattern. You have to fill the carbon like that. It's a hydrocarbon chain. CH3, CH2, CH2, CH2 is a fixed chain, always like that. You have to control the number of carbon. If it would be pentanoic acid, then I will be doing it CH3, CH2, CH2, CH2. 1 carbon will be there from COOH and total will be 5 carbon.
Okay.
So now you have to look at it carefully and you have to mark the right answer.
It's the first one.
CH3, CH2. Count the number of carbon in the first one.
No, CH3. I think it's the second one then, right?
CH3, CH2, CH2, CO2H. The first one. Why not
CO2H? CO2H is there because it's COOH, right? So CO2H.
Because that's fine, because COO is sometimes written as CO2. That's a pattern. This is not carbon dioxide. This is actually 1 carbon and 2 oxygen.
Yep.
Okay, now what should I mark for answer?
B.
Very good. What is this? Which molecule contain only single covalent bonds? Single covalent bond should be an alkane.
Alkane, yeah. A.
A. B, just for my discussion with you, for my revision, this is an alkane. This is what? For my revision, this is what? A carboxylic acid. What is this? This is?
The alkene, and the last one is an ester.
Yes, very good. What is the structure of propanol?
It's an alcohol.
Propanol, the letter OL means this is
Alcohol.
an alcohol.
So, there has to be OH. I think
Propanol.
it's propane.
Alcohol.
Propane. So there has to be 3 carbons.
Prop means, the word prop means 3 carbon, and alcohol means an OH group.
OH. So it's C.
Good judgment. Answer is C. Which statements about propene are correct? Propene contain only single bond. Propene is an alkene.
It's 2 and 4.
First one is wrong.
No, correct. Oh, no. I mean, yeah, first one is wrong. 2 is correct.
Color changes.
Yep.
It is obtained by cracking.
No.
Yes. Alkene. Alkenes are obtained by cracking alkane. Propene is a hydrocarbon.
Yes.
Which structure represents a molecule of ethanol?
C.
The structure of an ester is shown. What is the name of the ester? This part of an ester is the alkyl part. Okay. And this part is called the alkanoate. This is how you name it. How many carbon in the alkyl part?
3.
3. Very good. So it will be methane, ethane, propane. So it will be what?
Propyl.
Propyl. Acha. Alkanoate.
There's 2 carbons.
There will be 2 carbons. So it will be what?
Ethanoate.
Yes, it will be ethanoate. Overall, its name will be
Propyl ethanoate.
propyl ethanoate. Which structural formula represent methyl propanoate? It's an ester. Methyl is the alkyl part which comes after COO, and propanoate is the alkanoate part which comes before COO.
Hmm. Um, alkylate. I'm not sure.
Propanoate, methyl means one carbon. So one carbon after COO. This is COO, huh? This is the main link. So it should have one carbon after COO. This one, and this one. Methyl means
C.
one carbon after COO.
Alkyl is always after COO.
Alkyl comes after COO. Either it
Okay.
is A or C.
C.
I will cancel B and D. Why? Acha, propanoate. Propanoate means what? 3 carbon before C. Before COO. So you are right. C is the right answer. The pie chart represents the composition of natural gas. Which sector represents methane? Natural gas is more than 90% methane.
More than 90%.
Yes, more than 90% is methane.
So D.
This one, right?
Yep.
Hmm.
Okay, you go back up. Take a screenshot from the set. Yeah, done.
Now look, try this question. What is the main constituent of natural gas?
Mm,
We just did it here.
oh, methane.
Yes. Their favorite question. The fractional distillation of petroleum is shown. Which fraction is the least volatile? Least
Bitumen.
volatile is the most in bottom, lowest one.
Most viscous, right?
Hmm.
Bitumen.
Which fuel could be gasoline?
Obtained from petroleum. Yes. Use a food for cars. Yes. A.
Hmm. Petroleum is separated by fractional distillation. Which statement about the fractions produced is correct?
Uh, is it C?
Why C? Petroleum is separated fraction. Which statement about the fraction produced? Bottle gas for heating and cooking is obtained from the naphtha fraction. Diesel oil is used as a fuel for jet. D is wrong. Kerosene contain many useful waxes. D is also wrong.
I think it's, is it not C?
Uh, Bottle gas for heating and cooking is obtained from the naphtha fraction. It's very
It's
close, actually, very close. A and C are very close. So this is actually a memory of the uses. So you can look at the notes, you can recall.
I think it's either A or C, right?
There's an option is between A and C. The option is narrowed down to A and C.
I think it's C.
Logic, or you're talking about memory?
Memory. What is the answer?
But he can C is fine. Now look at this. Some fractions obtained from petroleum are listed.
Two is correct, I think. Yeah, two is correct. And I think two and three? No, no, no. Four is wrong, right? Because refinery gas is not above gasoline, it's below gasoline.
Hmm.
So it's two, but is two correct? Above. I
The
think
two says fraction is bitumen making road is right position collected in the above kerosene. It should be bitumen is on the lowest position.
is it not in the highest?
No, look at the diagram.
Like highest as in like, oh, like that. Okay. Then can you go back?
Hmm.
Okay, now can you go back?
Yes, now here it is.
So it's not two gasoline, it's not one. So I think it is, I think it's C of gas.
C.
Yes.
C means 3 and 4 only. 3 kerosene is used in jet fuel below gasoline, right? Refinery gas, heating and cooking above gasoline. Sahi hai. 3 and 4 is correct. Which statement is correct?
D. It's not B because oxygen is not a fuel. It's not C because methane is the main constituent of natural gas. And I don't think it's A. It's D.
Petroleum is separated into useful substances by fractional distillation, right?
I'll take a screenshot of that. Okay, continue.
Now, what is not the correct use of the fraction named?
Is it not A? It's A or B. Fuel oil making waxes. I think it's A.
Okay, how?
Yeah, I think it's A, right?
Answer is right, but how? Fuel
Because
oil.
C and D is correct, and
Hmm.
B is correct. Yeah, it's A.
The table shows the composition of 4 different types of petroleum. Which type of petroleum is best for the motor vehicle?
Fuel into the composition of how am I supposed to know? It doesn't show like.
Motor vehicles actually do not use kerosene. Motors run on gasoline or diesel oil. Actually, motor vehicles are either petrol vehicles or they run on diesel.
So petroleum is made up of gasoline, kerosene, diesel oil, and fuel oil.
Sorry.
Petroleum is made up of gasoline, kerosene, diesel, and fuel. Like petroleum is.
Petroleum. Actually, petroleum word is used in multiple senses. Here he says the petroleum coming from 4 different brands contain this. So he says which type of petroleum is best for, so which contain more quantity of gasoline and more quantity of diesel.
But I'm saying like petroleum can be broken down into all these.
No, actually, you're right, but you can say that 100% separation is perhaps not possible, but you can do that.
Okay. Then what's the answer?
You have to see one by one all the options which contain is the best for motor vehicle industry. Gasoline and diesel. Gasoline is highest in North Sea and diesel is highest in, look at the numbers.
Yeah, it's North Sea.
Which fraction of petroleum is not matched to its correct use?
Is it? Let me see. Let's see.
Yes.
Why? What is kerosene used for?
Kerosene is used in jet fuel. Na?
Oh, okay.
This is a memory table. The industrial fractional distillation of petroleum is shown. Which process happens at Y?
Is it cracking?
No.
Burning.
We evaporate the whole liquid and then it condenses back to their corresponding fractions. So at D, actually, we vaporize everything. Fuel, oil, gasoline, kerosene, and naphtha are four fractions obtained from the fractional distillation of petroleum. What is the order of the boiling point of these fractions? To answer this question, you can look at this. This is a very helpful screen and it shows the CI or Cambridge official way of observing how the fractions are shown up. The word naphtha, many people get confused with naphtha. Naphtha is a general word. Let me share this on the chat for our record. I have posted it on the chat so you can view it for reference. And now you can solve this question.
So fuel oil is the highest boiling point. It's either A or B. So, and then it's kerosene, yeah. And then naphtha and gasoline is B.
Hmm?
B.
Hmm. Which statement about homologous series and isomerism is correct?
It's not A or D. It's B. B.
B.
Yeah, B, like for ball.
Hmm. Okay, so we have done some questions today also. Organic is still in role and this topic will continue. Can you tell me, I'm searching for options because this class timing is colliding. And
Can you do like 2:30 to 3:30?
no, it's not working now. The problem is that my other commitments, Saturday, actually, Saturday sometimes become a working day also here. So I teach in colleges and etc.